Hello everybody, how are you? Today let's solve this lead code 337 house robber 3. Actually I haven't met the house robber 1 and 2. Let's get down to this 3 directly. Okay, so let's look at the problem first. A thief want to rob a neighborhood, and it's kind of like a binary tree. So we need to go through the binary tree for a maximum value, which we can only get from uh, non-directly linked nodes, right? In this example, uh, we can get to the maximum value from the first level values and the third level values. We got a maximum of 7. Or we can calculate the value by only the second level value, which is 5. That is less smaller than our maximum value 7, so we'll return 7 in this case. And in our second example, um, it's a different case. So in this case, the 4 and 5, the summation is 9, right? It's the maximum. Then we add up those four numbers, 3 and 131. Okay, so let's solve it. For binary trees, I think it's easy to think of it to solve with DFS. So first, let's try DFS. Um, let's first we need a helper function here to be to make us to make it make it easier for us to operate. So we call it a search. Oh, sorry. With only root, right? And we define the search function here. So the old tradition, if not root, we just return 0. And so the idea is to use DFS. So we can, if we want to use the root value, then we cannot use the left child and right child from that root value, right? So we can only use um, the child of the child. So if our root dot left exists, um, yeah, I think we need to add up a value, right? Our value should plus equal uh, to our recursion. So we want to get the maximum from the child of the child, right? And this is the root left dot left plus the right child. And we want to do the same thing for the right child. And then we can return the value now. The maximum value should be the maximum of we make use of the current value plus our the maximum of the child of the child, the grandchild, right? And or we do not use the current value. We use just the child maximum. So it should be the self dot uh, root dot left, I think plus the right child. Okay, yeah, I think we're done with this. Let's try. Time limit exceeded. The reason is the reason is when we go through the binary tree, um, uh, every time we want to calculate um, for every level, we may use it or not, and that would make us time complexity exponential. Um, so it would be the 2 to the power of n, right? The time complexity. And also the space complexity would be O of, um, I think, the number of nodes, right? So here we can use a DP to solve it. Here we introduce a memo. So if root in memo, we just return the value. And here we need to record the value every time we get an answer. Let's try it this time. Yeah, cool. You can see it's it's a great improvement. Yeah, when we use the memo here, I think the time complexity of big O of n, right? We only need to store, like save all those nodes in our memo. Cool, that's it. Have a good night. Thank you. Thanks for watching.